Hi, welcome back to my channel pibyme Maths. This is by WST01. Here we are solving January 2019 Statistics 1 paper. In part 1, we have covered question number 1 to 13. Let's look at question number 4. A group of 100 adults recorded the amount of time T minutes they spend exercising each day. Their results are summarized in the table below. Okay. In fact, sigma fx square is also given here. Remind me this value for later part if you are finding standard deviation or something. Okay, let's read part A. Put the table here again, just the class interval and the frequency. A histogram is drawn to represent the data. The bar representing 0 to 15, this bar, there will be a bar corresponding to this class interval, right? When you draw the histogram, the bar has a width of 0.5, height is 6 centimeter. Okay, using that information, they want you to find the width and height of the bar representing this class interval. Okay, usually when we draw the histogram for the width, we use the class width. Class width is 15 minus 0 is just 15. It's supposed to be 15, but they use some scale factor and reduce it to 0.5. So for this one, the class width is 120 minus 60 is 60. But what is the width on the histogram? That's a question. So you just cross multiply and find the width. 15W is equal to 0.5 times 60. W is this 30 divided by 15 is 2 centimeter. That's all. And we are going to use the same method for height also. For height, we usually use the frequency density, which is frequency over class width, right? Okay. Let's look at the first bar now. Sorry, first class interval, this one. The frequency is 25, class width is 15. The height supposed to be 25 over 15, but they have used 6 centimeter. So for the blue one, the class width, the frequency density is supposed to be 24 over 60. But what's the height on the histogram? That's a question. Cross multiply again. 25 over 15 is 5 over 3 times height is 6 times 24 over 60. That's basically 6 times 24 over 60. 12 over 5. So H is equal to, you can write one more step. H is equal to 12 over 5 times 3 over 5. .44 centimeter is the answer. That's all. It's a 3-mark question. Let's move on to part B. Use linear interpolation. So I put the table here again. Use linear interpolation to find the median. To find the median Q2, you need to divide the sigma f by 2. Sigma f is given here. There are 100 adults. So we are going to divide 100 over 2, which is 50. Now write the cumulative frequency here. Cumulative frequency is 25. 25 plus 17 is 35. 42 plus 28 is 70. 96 and 94 plus 6 is 100. The last value should be 100. Okay, now we need to check where this 50 lies in the cumulative frequency. Anything more than 42 till 70 lies in here. Take the class interval 30 to 60. 30 to 60. Put Q2 in between. Take the corresponding cumulative and the previous cumulative 42, 70. Write this 50 here. And then apply linear interpolation. Q2 minus this divided by 60 minus this. $50 minus this divided by 70 minus this will be in the same proportion. 50 minus 42 over 70 minus 40. So Q2 is 50 minus 42 is 8 over 70 minus 42 is 28 times, when you bring the denominator to the other side, 30 plus, when you bring minus 30 here, it becomes plus 30. So you get the value of Q2. So Q2 is 8 over 28 times 30 plus 30. 38.57 etc. Round it to 3 significant figure. 38.6. That's the median. Part C now. Find an estimate of the mean time spent exercising by these adults each day. So first you need to find the midpoint, which is given here already. So the formula to find the mean x bar is sigma fx over sigma f. Sigma fx is, you need to draw another column and find fx first. F times x. 25 times 7.5, which is 1.8. You can just write it as one shot actually. You can write, we know sigma f is there are 100 adults. Sigma fx is, just write 25 times 7.5 plus 17 times 22.5 plus 28 times 45 plus 24 times 90 plus 6 times 180 divided by 100. So we have to calculate this carefully. 25 times 7.5 plus 17 times 22.5 plus 28 times 45 plus 24 times 90 plus 6 times 180. 5070. So if you want, you can write 5070 over 100 50.7. That's the mean. Now part D, find the standard deviation. The formula to find the standard deviation sigma is square root of variance of x. Sigma fx square over sigma f minus the square of the mean. So you can write fx square is given here 455,512.5 divided by 100 minus the mean we just calculated, mean 50.7, the square of the mean and square root of everything. So it's basically square root of 455,512.5 over 100 minus 50.7 square. 44.549 dot. You can round it to 3 significant figure or leave it as it is. 44.5 is answer. Part E now. Describe, giving the reason, the skewness of this data. Okay, I'm going to paste a picture here. These are all the conditions for positive skewness. If the histogram is skewed towards this 0, if Q2 is closer to Q1 than to Q3, if it's closer, the difference between these two will be smaller than the difference between these two. Our median is smaller than mean. If it's smaller, the mean is a bigger number, so when you subtract, you will get a positive number. So these are all the conditions for positive skewness. You can use any one of the conditions. If it's the opposite way, for example, the histogram is this way. If Q2 is closer to Q3, if it's bigger, median is bigger. If median is bigger, automatically this is going to be a negative number, right? These are all the conditions for negative skewness. You can take note of this picture. Okay, now in this case, since we have mean and median, I'm going to compare the median and mean. We have calculated median here. Median is 38.6. Median 38.6. Mean is, we just calculated mean 50.7 is smaller than 50.7 mean. If median is smaller than mean, it's positive skew. Therefore, positive skew. You cannot just write positive skew. You need to give a reason. So this is the reason. That's just a 1 mark question. Next one. Further analysis of the above data revealed that 18 of the 25 adults in this group. Okay, let me put the table here. I have put the table here. It's a 3 mark question. Each carries 1 mark. This also 1 mark. Okay. Anyway, further analysis of the above data revealed that 18 of the 25 adults, there are 25 adults in this group, in this class interval 0 to 15, right? Out of this 25, 18 of them took no exercise each day. Okay, you need to understand this class interval. What do they mean by 0 to 15, 25 of them? So we don't know how many of them out of this 25, how many of them took how much time, right? But we put them as a group. That means all 25 of them, the middle point is 7.5. So we are going to assume that all 25 of them took 7.5 minutes to calculate the mean and median and etc. Right? So not for median, to find the mean. So that's how we assume, right? But now it says 18 of them no exercise. So this becomes, instead of 25, it's going to be 7 now, right? Because 18 of them it's 0, right? So for 18 of them there is no midpoint, it's going to be 0. Okay. Now the question says, state giving a reason what effect, if any, this new information would have on your answers to the median. We have calculated the median as 38.6. 38.6, right? 38.6 lies in this class interval between 30 to 60, correct? So this, whatever changes we are making here is in the first class interval. It's not going to affect the median because all these 18 values are also below the median, right? So you can write for median, for this one, no change. You can't just write no change, you need to give a reason. So you should write the reason as the new information only changes the distribution in 0 to 15, correct? So if we can divide into 8 plus 18, this is 25 plus 17 is still 42. Still there are 42 students below the median. Therefore the median will not change. That's the answer for I. Now let's look at double I now. What will happen to the mean? To find mean, we are multiplying 25 by 7.5, right? When you multiply 25 times 7.5, you are going to get 187.5, right? But now we know 18 of them took no exercise, so we are going to multiply by 0, and balance 7 we multiply by 7.5, right? So you need to write for double I, instead of 25 times 7.5, now it's 7 times 7.5. Therefore the value decreases. So this sigma fx is the numerator when you find the mean. So when the numerator decreases, automatically mean will decrease because sigma fx is reduced now, right? Let's look at triple I now. Now what will happen to the standard deviation? Okay, listen me carefully. Before it was 25 of m and the timing is between 0 to 15. We don't know the exact time. We take the midpoint, that means 7.5. So somewhat all these timings of 25 adults are closer to 7.5, right? That's why we group them to 0 to 15, and we assume that all of their time is closer to maybe some of them 7.5, maybe some of them 6, 7, 11. It should be 0 to 15, right? 15. The spread from the midpoint will be all the points are closer to 7.5. Now 18 of them are not taking any exercise, so 18 zeros. Instead of this, we are going to have 18 zeros actually. So the spread will be more also, right? Or if you want to compare with the mean is 50 point something, let's say 50 to 7.5, the spread is 42.5, right? Now there are 18 zeros, so 50 minus 0 is 50. From the mean, the spread is gonna increase actually because there are a lot of zeros. Standard deviation says how the data is spread out, right? So you have to write SD will increase because now the data is more spread out. That's all. That's another one more question. Let's move on to question number 5 now. Some children are playing a game involving throwing a ball into a bucket. Okay, each child has 3 throws, and the number of times the ball lands in the bucket X is recorded. That means there are many childs actually. How many of them? 16 plus this is 40, 52 plus this is 76 plus 4. There are 80 children actually. Okay, each child has 3 throws. You need to understand what do they mean by 0 is equal to 16 frequency. Each child has, okay, I'm gonna call it child 1, child 2, child 3, etc. We have child 80. Each child has 3 throws actually. So 16 of them, they did not put the ball into the bucket. They use all their 3 throws. Maybe here this child has not managed to put the ball in the bucket. Maybe another one, C4, C5. So 16 of them did not manage to put the ball in the bucket at all. 1 is equal to 36 means now the 36 children, they manage out of their 3 throws, they managed to put the ball in the bucket once actually. 24 children, they managed to put the ball in the bucket twice out of the 3 throws. And only 4 of them managed to put the ball in the bucket in all 3 throws actually. So that's what it says. You need to understand this. Okay, find X bar. That's very simple. The formula is sigma fx over sigma f. So 0 times 16, 1 times 36, 2 times 24, 3 times 4, that's sigma fx divided by 16 plus 36 plus 24 plus 4. So that's going to be 36 plus 48, 2 times 24 plus 12, 96 over 80. 96 over 80 is 6 over 5. 1.2. That's all. Just a 2 mark question. Let's look at part B now. Sandra decides to model the game by assuming that on each throw, the probability of ball landing in the bucket, let's call it success. Probability of success is 0.4. So definitely probability of failure will be 1 minus probability of success, which is 0.6, right? Okay. For every child on every throw, and that the throws are all independent. Why they use the word throws are all independent, I will explain this. If you are taking statistics 2, there is something called binomial distribution. The probability function is NCX P power X Q power N minus X. That's probability of success, probability of failure. I would advise you all to go through this little chapter. It's very easy. You can just spend like 30 minutes to go through it, because usually in S1, mostly for chapter 7 normal distribution, they add question like this, actually a binomial distribution. In fact, this is a binomial distribution. That's why for binomial distribution to apply this, all the events should be independent of each other. That's why they have given this line that the throws are all independent. Okay. So now, what if you don't want to learn binomial distribution? There is another way to solve it. I will show you that also. The random variable S represents the number of times the ball lands in the bucket for a randomly selected child. The ball lands in the bucket 2 times actually. That means 2 success out of 3 throw. It can be first 2 success failure, or success failure success, or failure success. There are 3 combinations. The probability of success here, which is 0.4 times 0.4, probability of failure 0.6. Here also the same thing, right? Here also the same thing. So when you add them, it's basically P of S is equal to 2 is 3 times 0.4 to the power 2 times 0.6. So you will get the answer already. 3 times 0.4 square times 0.6. 0.288. How do we use the binomial distribution here? There are 3 throws, n is equal to 3. So S follows binomial distribution of 3, probability of success. So P of S is equal to 2 is NC2 success power 2 failure power 3 minus 2. You will get the same answer. That's binomial distribution basically. Basically what we are doing here is binomial distribution, but we are writing each combinations actually. Complete the table below to show the probability distribution for S. Okay. First, 0 means no success at all. P of S is equal to 0 means a child has 3 throws, all 3 are failure. So it's basically 0.6. That's a probability of failure, right? Which is 0.6 to the power 3. 0.216. How to find this? You don't have to calculate it. We know sigma, sum of all the probability should be equal to 1. Okay, wait. This one we calculated in the previous part already, right? 0.288. 0.288. If it's not there in part A, you just sum up rest of the probabilities, subtract from 1. Anyway, now we need to make sure whenever you draw a probability distribution table, make sure the sum of the probabilities is equal to 1. So 0.216 plus 0.432 plus 0.288 plus 0.064 is 1. That means it's perfect. Just a 1 more question. The next one now. Ting believes that the probability of ball landing in a bucket is not the same for each throw. Okay, here Sandra believes that the probability is 0.4 for each throw. But here another person, Ting, believes that the probability is not same actually, because every time you start throwing the ball, it's gonna get it's going to get better. So he is suggesting a new model. Pi is equal to this. That means P1, for P1 it's 0.15 times 1 plus 0.10. For P2, 0.15 times 2, 0.10. For P3, 0.15 times 3, 0.10. Let's calculate these properties first. 0.15 times 1 is the same, plus 0.10. 0.25 plus 0.25 times 2, so I'm going to add one more 0.15. 0.4 times 3, so I'm going to add one more 0.15. 0.55. It's just the probabilities. Don't think that all the sum of these probabilities should be equal to 1. Not necessarily. You can see the probabilities is getting higher and higher. So in the first row, the probability is low, and when you throw second time, you are getting better, so the probability gets bigger actually. In the third row, it's 0.55. Okay. Now, I is 1, 2, 3. P is a probability that the ith throw of the ball by any particular child will land in the bucket. The random variable T represents the number of times the ball lands in the bucket for a randomly selected child using Things model. Okay. First, I'm going to put this P1, P2, P3 here. 0.25, 0.4, 0.55. Now show that P of T is equal to 3. What do they mean by T is equal to 3? That means 3 times out of 3 throws, all 3 times the ball lands in the bucket. Right? So the first time also the ball lands in the bucket. So this is the probability. Second time also, third time also. So it's basically 0.25 times 0.4 times 0.55. 0.25 times 0.4 times 0.55. 0.055. We got the answer already. That's I. Double I. What do they mean by P of T is equal to 1? Out of 3 throws, the child managed to put the ball into the bucket only once. It can be the first one, the second one is failure, third one is also failure. Or it can be the second throw, so the first one, third one is failure. So the child manages to put the ball in the bucket in the third throw. So first 2 are failure. So that's why I put complement P3. So P1 is 0.25. P2 complement of this is 1 minus 0.4. So 0.6. 1 minus P3 complement is 1 minus this 0.45 plus P1 complement P2 P3 complement plus P1 complement 0.75 P2 complement P3. We need to calculate this. 0.25 times 0.6 times 0.45 plus 0.75 P1 complement times 0.4 times 0.45 plus 0.75 times 0.6 times 0.55. We got the answer already. Is equal to, they want us to prove that it's 0.45. That's all. Let's move on to the next part. They want us to complete the table. Okay, we just calculated 1 and 3. We need to calculate 0 or 3. Okay, let's 0 or 2. We calculate one of them and then sum of the probability is 1. So add everything, subtract from 1. I'm going to calculate P of T is equal to 0. All 3 failures. So P1 complement times P2 complement times P3 complement, which is 0.75 times 1 minus P2 and then 1 minus P3. 0.75 times 0.6 times 0.45. 0.2025. So for this one, you can just add everything, subtract from 1. So P of t is equal to 2 is 1 minus 0.2025, 0.45 plus 0.055. 0.45 plus 0.055 minus 1. 0.2925. So write 0.2925 here. That's all. Part F now. I have put all the 3 tables here to explain this question. State giving your reasons whether Sandra's model or Things model is more appropriate for modeling this game. This is the actual observed value, the x and frequency, there is no probability. And this is Sandra's model, Things model with the probabilities. So what we are going to do now, we are going to find the probabilities corresponding to these values. There are a total of 80 child, so 16 over 18. You can write P of x is equal to x is 16 over 80, get this value 36 over 80, 24 over 80, 4 over 80. This is 0.2. 36 over 80 is 0.45. 24 over 80, 0.3. 4 over 80, 0.05. Now compare the probability. For example, the first one, compare this probabilities with Sandra's probability and Things probability and check which one is closer. The observed probability is 0.2, Sandra's one is 0.216, Things probability is 0.2025. Definitely this number is closer to 0.2, correct? Okay. How about the next one? Next one, 0.45, definitely not this. This is exactly same, right? How about the third one, 0.3? You have 0.288, 0.2929 is closer, right? When you take the next probability, 0.06, 0.055, 0.55 is closer. So in every case, in every value, for every value of x, the Things probability is closer to, you need to write Things probability probabilities are closer to the observed probabilities. So therefore, Things model is appropriate. That's all. Let's look at question number 6. Following some school examinations, Chetna is studying the results of the 16 students in her class. So N is 16. The mark for paper 1 X is the marks in paper 1. For paper 2 it's Y for each students are summarized below. Comment on the differences between the marks of students on paper 1 and 2. It's a 2-mark question. You can write X bar 35.75. X bar is greater than Y bar, right? Therefore, therefore the average score paper 1 is higher than the average score in paper 2. Now let's look at sigma x and sigma y. Because the standard deviation tells us how spread the data is. Sigma y is bigger than sigma x. If the standard deviation is smaller, that means the data is closer to a midpoint. That means the marks are more consistent here. The spread is smaller. If the standard deviation is bigger, the spread is bigger. The data is more spread out, so the marks are not consistent actually. So you can say the score in paper 2 is more spread out compared to P1. Let's move on to next part. Chetna decides to examine this data in more detail and plots the mark for each of the 16 students on a scatter diagram. You have a scatter diagram given here. Okay. But we explain why the circle point is possibly an outlier. This is a circle point. Definitely it's more deviated from the other values, right? So you can write the point 380 is far from the trend line or trend or line of best fit. That's the reason. Suggests a possible reason, this is I. Suggests a possible reason for this result. 38, 0. 38 is x, y is 0. That means in paper 1 the student scored 38, in paper 2 the score is 0. Why it's 0? Instead of just writing the student scored 0, you can write maybe the student is absent for the exam. The student was absent for P2. Chetna decides to omit the data 380 and examine the other 15 student mark. Find the x bar and y bar. We have x bar for 16 students, which is given here, 35.75. 35.75. So x bar is sigma x over 16, right? So you can find sigma x, which is 35.75. $572 is sum of the scores of all 16 students in paper 1. But we are removing 38 now. So sigma x for 15 students now, because we are removing one student. So 572 minus 38. 534. Therefore, new x bar is 534 divided by 15 students now, right? 178 over 5. Or you can write it as 35.6. The same way we can find y bar also. Previously the y bar was 25.75. 25.75. That was sigma y. So sigma y is 25.75 times 16. 25.75 times 16. 412. Now new sigma y is going to be 412 minus this student scored only 0. So that's gonna stay the same. Therefore, new y bar will not be the same, because now we are going to divide by 15 instead of 16. 412 over 15. I'm going to keep it as it is because it's a recurring decimal. Part D now. Explain why sigma xy is still this. How do we find sigma xy? We take x and y, we multiply the values, and then we sum up whatever the result we are getting, right? For the student who scored 38, the y is 0, so when you multiply, it's 0. So for 16 students also, when you add everything, you're going to add, let's say this is xy. You have some numbers here, but this is going to be 0. Even you take 15 students also, you're going to neglect this. You are neglecting 0, so basically it's still the same thing, right? So you need to write the sigma xy new is equal to 15837 minus 38 times 0. Therefore, no change. And then double I find Sxy. Let's use the formula for Sxy. Sxy is sigma xy minus sigma x times sigma y over n. 15837 minus, we have calculated sigma x and sigma y here, right? 534 and 412. That's a new sigma x and sigma y, right? 534 times 412 divided by 15. 15837 minus 534 times 412 over 15. 1169.8. That's all. Let's look at the next part now. For these 15 students, she calculated SXX, SYY, find PMCC. The formula is SXY over square root of SXX times SYY. We just calculated SXY here, 1169.8 divided by square root of 965.6. Take it from the question, 1561.7. You get the answer already. So this answer divided by square root of 965.6 times 1561.7. 0.95260, 0.95260 dot dot dot, rounded to 3 significant figure, 953 is the answer. Part F. Calculate the equation of the line of regression of y on x for these 15 students, giving you answer in this form. Okay, let's find B first. The formula is Sxy over Sxx. So Sxy is, we just calculated here, 1169.8 over Sxx, which is 965.6. So 1169.8 over 965.6. 1.2114 dot dot dot. I'm gonna store this value as B. Now let's find A. The formula is y bar minus B x bar. We have calculated y bar here, which is this, the circled one. 412 over 15. 412 over 15 minus B times x bar. We have calculated x bar here, 35.6. So let's find A now. 412 over 15, y bar minus B, I stored the value as B, times x bar, minus 15.661 minus 15.661 dot dot dot. Therefore, the regression line is round the values of A and B to 3 significant figure. So it's going to be minus, A is minus 15.7, plus bx 1.21x. That's all. Let's look at the last part of the question. The product moment correlation coefficient for x and y, we have already calculated R for 15 students. Here 0. Let's take it as 953. But for the 16 students it was calculated and they got 0.746. Part G, explain how your calculation in part E is this. The PMCC supports Chestnut's decision to omit the point before calculating the equation of the regression line. Okay, R is, the value of R is increase from 0.746 to 0.953. What does that mean? When the product moment correlation coefficient PMCC is the value, the more closer to this value, to positive one, the more stronger the positive correlation will be. So from 0.746 to 953, it increased. That means the points will be more closer to the line of best fit. So because we are omitting this point, the value of R increased from 0.746 to 0.953. So by omitting this point, the rest of the points will be closer to the line of best fit. So you need to write, therefore the points lie closer to the line of best fit. Okay, so that's the explanation here. Okay, now H, estimate the mark in the second paper, that's Y, for a student who scored X is 38. So you take the regression line, Y is equal to, this is a regression line, but do not use the rounded value, you need to use the actual value. We have the actual value of A here, I'm gonna store it as A. I should have stored it before. Okay, so Y is minus 15.7 plus B is 1.211, 15.766 times 38. You will get the answer. In the calculator, I'm going to simply put A plus B times 38. 30.374, etc. So Y is basically 30 marks. Or even you can just leave it as it is or round it to 3 significant figure. 30.4 is also correct. That's all.